Let us start the video session. This is an online lecture on reviewing the topics of Unit 1, and we are going to study Software Engineering Unit 1, that is the course of COC 2090. And this lecture is specifically taken for people who want to review the course. So start with the basic definition of software engineering. So software engineering is the basic sound in the implementation of the engineering principles that lays the foundation of all the software engineering work products. But the main focus is on quality, right? The software that we going to like build, or we going to create, the main focus is the commitment should be on the quality part. So it will always be the quality which will be the prime focus, and along with the quality the system should create economical softwares that are reliable and work efficiently on the real machines. So I cannot create like thought of an idea that I want to do something and I will propose the idea and I will just step down now. Like I want the sort of idea that I propose should actually work on a real machine, right? And the idea should be converted into the work products and economical softwares, and the system should be reliable enough. Reliable in the sense that the system should recover from its faults on its own. Basically, when you see our Windows updates, or you can see something like what you can say MS Word also, it has an autosave feature. Autosave feature allows you to do what you can do with autosave feature. It helps you to retain the information back. If you, in case the Windows crashes somehow or Word crashes somehow, you don't lose the data. It rolls back to a particular point till where he has already saved. You might lose certain data, but not the complete data. So the system is much more reliable than the previous versions. Now, to how to maintain quality, the two approaches that helps us to maintain quality, one is called the TQM, total quality management, and one is called Six Sigma approach. So TQM generally was an older approach that was followed for maintaining the quality. The main focus was, once the system delivers a product to the client, the system tries to maintain the quality, and it sees that the system, the next product that goes into the customer, that goes to the customer, is of the same quality level. It's not degraded in quality. But the Six Sigma approach that was initiated in some 12 13 years back, this approach tries to monitor the system continuously, right, and suggest improvements in the system. So it is a form of a continuous improvement, process improvement, like culture. It generates this type of culture in which I will see certain if I deliver a product to a customer, I will wait for the reviews, I will wait for the comments, I will wait for the feedback. Once I get the feedback, I will try to and accommodate these feedbacks into my next future releases. And then it will create more of a sophisticated and more economical or more reliable software in the new release. Whichever release it comes in next, the system will be much more efficient than the previous version. So it keeps on increasing the efficiency. It will keep on continuously improving the process of the software development. So Six Sigma has these five basic stages which is written here. One is called the define stage, in which the requirements are collected through the customers. It's a requirement engineering phase. The second is a measure phase, in which we will critically analyze the requirements, that what are the right requirements, what are invalid requirements, which requirements can go into what releases, and what amount of data they actually require. And the third is the analyze phase, in which we analyze the problem, and then we improve or mitigate the particular software. Like, what do you mean by mitigation? Mitigation means, if I find certain deficiency, if I find a bug somewhere in the code, right, then what happens is I will try to fix the bug first, right? Then after fixing the bug, I should write down why this bug actually appeared, how I like resolve this bug, and is this bug the only bug in the complete software. So if I have recovered this bug somehow, then the rest of software will be like bug free, right? So that particular bug, if that is the case, the bug was the root cause. Otherwise what will happen, the bug will retains in some module of your code, and you are trying to fix it from another module. So once module, the dependent module is bug free, but the original module that has created the bug still is there. So the root cause has not been removed. And finally there is there is a control step which sustain the improvement. And whenever you do certain changes, it will try to maintain, it will try to read the data that how much is the sustenance of the improvement. So these are some of the approaches for quality management. And the foundation of the software engineering is on the process layer. That means above the quality there is a layer called process layer. So if I go and see you this, if you can see this, then you can see that above the quality is the prime focus of the customer of the software engineering. Above the quality there is a layer of process. Okay, the process is the foundation. The process defines the framework that must be established for effectively delivering the software engineering technology. Right? Like if you go a market and you want to buy a product, you will try to buy a product from a branded source, right? Why? Because you feel comfortable, or you are assured that the process they followed are very strict, and they will have a particular process of delivering the system. If you want to eat like eat something, you will go to McDonald's. If you want to eat McDonald's from Aligarh, or you go and eat McDonald's from Connaught Place, any other place in India, the how the taste remain the same. Why? Because the process they follow is exactly the same on each location, right? So if you define the process, then in that case the process makes it it is. Do you want to ask something, Ujjwal? Sorry, I was muted. Okay, so you missed something. Okay, let me go back again. Till now, we were discussing about process only. So quickly, you must have seen the slides. So what I was discussing was what is software engineering and what is the process basically. So the process that you follow will ensure the quality. That is what I want to explain right now, that the process that is we defined a process, we need the help of process to maintain the quality of the software. Now if we see this particular importance of process, it forms the basis of the management control of software projects. It establishes the context in which the technical methods are applied. It takes case of the work products that are being generated. That means whatever work products may be a model, may be a document, may be a data, or maybe a report. Okay, anything that is delivered as a part of the software delivery, right, is a work product. And what all work products should be delivered is the part of the process. The process will keep on monitoring that one phase is over, requirement phase is over, the SRS should be delivered. The design phase is over, the design document should be delivered. The coding phase and testing phase are over, then the test coding and testing documents, related documents should be ready. And finally, deployment is over, the complete technical document should be ready. So the thing is, each phase needs certain outputs, right? So the work products come out of the each phase of the software development, and the process tries to maintain that you when you reach the end of the phase, the particular data or particular type work product should be generated. And likewise, that's what the last point says. It establishes the milestones, ensure quality and manage changes in a controlled way. So if you know you that at the end of the requirement engineering phase, you have not completed your SRS, that means either the requirement engineering is in progress, it is not completed, or you have missed certain process like regarding creation of that particular document. So you can do a fast work and can complete of the remaining part of the software requirement analysis. Now, the if you know the importance of process, then how to implement process is just an idea, right? It is generally a set of rules that I put in. Now, to how to implement process is through certain methods that I have to create, and the methods are implemented using certain tools. So this is the layered approach that has been explained in your textbooks, which says the tools are on top of the layer, then come the methods, then the process, and finally the quality. Now, if we talk of the process, now we will work on one process that is applied through software engineering and which is of certain use to software practitioners. It is called the SDLC. SDLC might have different names, but generally we call them as software development life cycle, the second one, when we are more concerned of developing a software as a service. Okay. Now SDLC stands for Software Development Life Cycle, and it is a generic process framework. What do you mean generic? That means all the steps that are there in this particular framework or the life cycle is applicable throughout the software development activity. It doesn't bother that if you are following a waterfall model or a spiral model or a rad model, the phases will remain near about same. It is the same process that is followed, but the occurrence might have certain different procedure, but the phases might remain always the same. So the software process, how it does it is identify a small number of framework activities, okay, and that are applicable to software regardless of size and the complexity. How much big the process is, how much small the process is, it doesn't changes. The activity will remain same. The stages are five in there are five stages of SDLC. One is the called communication stage. It is a stage in which the customer tries to do a heavy communication with the client, with the developer, and it try to collaborate with the developer and do requirement gathering. So both the parties have to come sit together. They will discuss what requirements they want and how they are going to what are activities they actually looks in for the development. This is the communication for the starting phase of SDLC. The next phase is called the planning phase. Once you are done with the requirement, the next phase is you want to plan. What you want to plan? I want to plan the risk that is being associated with the particular scenario or particular development. I can plan the technical task that needs to be conducted. Okay, what works need to be done, because I might have done already in the past certain projects or a similar sort, so I don't want to repeat the technical task. I can just take them as a reference and start from the new task that is available to me, right? And then a risk means something that happens with a probability of failure, an event that can lead to a failure, and if the failure occurs, then what should I do? This is called mitigation, right? Then if the risk occurs, then what should I do? If a device is there, suppose there's a firewall or there's a switch which is heavily loaded, if the switch goes down in a network, the network will be standstill, right? It will not work. So in that case, if the system goes down, then I should have a backup server ready. This is the risk component, right? If I have a resource like a human resource, a person is there who is highly skilled, but the probability is that he can switch the role, he can switch the company. Then I should have a proper backup of that person. That somebody should be there who has equal information and knowledge as per as that person has. The resources that will be required, the software resources, the hardware resources, or the human resources that are required to implement the project. All these things are part of the planning activity. Okay, not only the cost that we will you have studied as a Kokomo model, but yes, all the things that technical tasks, risk, resources, work product, work schedule, all are a part of the planning activity. So, in case anything is not clear to anyone, you can just unmute yourself and you can ask. Okay, say it out, because sometimes I doesn't come back to uh, this Google Meet and see the comments, or I will take the comments at the last when I have end of this particular session. The third activity is called modeling. Modeling activity take care of creation of models You can create design models or you can create UML models, because you have already done requirement engineering initially. So you know the requirements. You can create UML models, the UML model that can help you create like elicitate the requirements or elaborate the requirements, are like what use case diagrams or the sequence diagrams, activity diagrams that we have studied in the class, and I have shared a video also on the classroom for you to study. So these are the models that we create to understand the requirements and the design that will achieve those requirements. The fourth is the construction phase. The construction phase actually encompasses two activities. One is called the coding, code generation of the system, and the testing part. Okay. Now testing parts itself has two components. One is the unit testing and one is called the system testing. Unit testing is had to be done by the like the developer itself. So because you are the one who is creating the code, right? So you are the best person to test that code. It's a responsibility of the developer to test that code itself. So this testing that we talk about, that uncovers the errors, is encompassing two things: system testing and unit testing. But once you generate a code, the next step is to do a unit test. Once you are done with a unit test and you ensures that you assure yourself that there's no error in the code passes to the testing level. Okay, or your system production area, where the tester or the business analyst tests that particular code. This is the system testing part. And finally, there's a stage called deployment, the software in which the software is delivered to the customer and waited for the feedback. But the deployment or the delivery is can be a full software. Okay, I created the software and deploy it to the customer side at one go, or I can create increments of the software, that in first increment this much requirements will be delivered, the second increment the second type of requirement will be delivered. So as a partial computer increments I can deliver, or a complete entity I can deliver, but the deployment is the final stage of SDLC. So is SDLC clear to all the students who are here present here? Anyone can say yes or no if you are hearing this. Now going ahead with SDLC. After SDLC, you must understand that how to implement these stages, because SDLC is generic process framework. Okay, it has 5 activities. You should remember these activities by heart, because it's very important to know. Now the next thing is the models. Okay, so the SDLC is implemented by means of different process models, and we will see these 4 basic categories of models in this particular unit, that is waterfall model, increment process models, evolutionary process models, and component based model. Okay, so you can see that word called model. When I talk model, that means this is the only model in that particular segment, right? If I say increment process models, this particular segment has 2 models in it. Okay, evolution process model has 2 sub models in it, and the component model is a single model. So let us start with waterfall model. So waterfall model is called the classic life cycle model. It suggests a systematic sequential approach to software development following the activities as mentioned in the SDLC framework. Now, the main thing is you should remember that which model to choose from what type of activity is the requirement of the model. The first requirement is this type of model is used when we have a requirement that is well defined and reasonably stable. That means the requirement that we have gathered in the requirement engineering phase are so short and so clear that we don't want to redefine it in the futures. Right? I don't want the customer will never want a change in the future. He is very clear about what he wants, and you are very clear how to implement. Okay, both the parties are very clear in what they actually have to do and though actually they want, and it is really stable. That means they will not change in the future. If you having such requirement in which the things are extremely clear in the initials and it is stable also, you will choose waterfall model. For example, if I give you a program in implement C factorial of a number, right? The factorial of a number is such a small trivial problem that it doesn't require any like changes in the system, right? And the requirement is to give an input a number, you will the system will create a factorial and it will display a factorial number, right? So it will not change. This is a small example. The softwares are much more bigger than this particular thing, but if I say to state this, if you have certain requirements which are stable in nature and which is well defined, you will choose waterfall model. So waterfall model has all these five activities, and the sub part of the activities are here mentioned. Like communication has project initiation and requirement gathering part. Planning has estimation, scheduling and tracking part. Modeling has analysis and design part. Custom has code and test, and final deployment has delivery support and feedback. So if this is a good model, then it should be followed in industry. But the reason why it is not followed in industry is because of these drawbacks. So the drawback says that it's very rare especially rare project rarely software product rarely follow this sequential flow, because in industry we generally doesn't follow sequential flow. Okay, we follow certain ad hoc steps. So it is often difficult for the customer to state all the requirement explicitly. Okay, that means that the customer is hardly has this capability to define all the requirements at one go, right? Because you cannot foresee the project last for say 1 year or 10 months or 12 months projects. So you cannot foresee all the requirements at one time. So you can have certain overview that I want this particular requirement, but some requirement might be added or some requirement might be dropped in between. So the customer is not especially defining all the requirements. The third drawback is the customer must have patience, because if you see the definition of waterfall model, it says that the project will be delivered. The customer can only see the final version of the problem or the solution after the product has been completely built. Okay, in between there is no communication between the customer and the developer or the company. So a working version of the programs will not be available until late in the project timeline span. So for that the customer should have patience. And in general, customer doesn't have patience. He want to see certain things is been in progress or not. He want to see a prototype. He want to see a dummy module, something like that. So that's why this type of model is not feasible in a particular real life system. Now, if this is the drawbacks, how to overcome the drawbacks? We will overcome these drawbacks with the help of another model which is called iterative models. Okay. So in many situations, the initial software requirement is reasonably well defined. So I will define the software requirement very well. Okay. However, there may be a compelling need to modify a limited set of software functionality to users and then refine and expand on the functionality in the later software releases. So it might be possible that I reasonably define all software, but I may require some more changes in the future. Okay. In all such cases, it is advisable to use the incremental process models. So now what is happening is the well-definedness is there, but stability is not there. Okay. The stability is now missing somehow. Somehow it is missing. So what is happening here is now we change the model. Okay, so you have if you create a matrix, if we have two columns, one column is called well-defined requirements and the second column is stability. The waterfall model is selected based on the condition that both are checked out, right? The incremental process model is used when the well-definedness is checked but the stability is not checked out. Okay, now what are the sub process of incremental process model? One is called the incremental model and one is called the rapid application development model, RAD model. Now, incremental model is a model in which I will follow the 5 stages communication, planning, modeling, construction, and deployment. But I have increments. So I will like, because the requirements are well defined. So what I will do, I know all the requirements, but I will create chunks of deliveries, increments. In the first increment, which all requirements should be going. The second chunk says in the second iteration which all requirements should be going. And the third increment says which all requirements should be going. So in the three increments, I will complete the complete scenario. This type of thing also is useful when you know the complete requirements, but you don't have the limit like workforce number of people who can do at one go. Okay, you have limited resources at your end. So what you will do, you will have to utilize the number of persons who are with you to development, as well as you have to deliver the product. So that same person will be involved in delivering the first release. The same person will be used in delivering the second release, and the same person can do it will be available in delivering the third release of the software, in which we have utilized the number of resources also, and we delivered the software also in multiple increments. When an increment model is used, the first increment is often called as the core product. So the first increment that we see at the bottom is called the core product. Why is it called a core product? Because all the increments that is built will be on top of this particular first increment. So whatever functionality goes into this first increment should always serve as a basis for the further increments that is being delivered to the client. So the core product addresses the basic requirements, and supplementary requirements are still undelivered, and the core product is evaluated by the customer. Incremental development is a particularly useful when the staffing is unavailable for a complete implementation of the business deadline. That was I talking about that. Now you have additional requirements for selecting incremental model. That is, the staffing is less, right? So I can add increments because of the staffing is less. I have this limited staff and I want to deliver the product. Along with this, I can manage technical risk, because if I have a project, if I send it into one release, the customer will start evaluating after the deployment part. The green box at the last is a deployment box. Once it goes out to the customer starts evaluating this particular increment. Meanwhile, I start requirement engineering and planning. I will get some feedback back from the customers. So I can plan technical risk in the second increment itself. Okay, instead of waiting for the last stage, I can start planning that technical risk in the planning part of the second increment, and likewise the planning part of the third increment. So I am managing the technical risk efficiently in this incremental model. Now RAD is another type of increment model, but it overcomes the scenario where the staffing is less. Okay, now suppose you have the sufficient staff available to you, but the time slot that is given to you is very short. Okay, in the RAD model is applied only where the time slot given to you is extremely short, and you have like sufficient staff to deliver that particular project. So in all this case, RAD is a very high speed adaptation of waterfall model, in which the rapid development is achieved by using component based construction approach. It also use approach based component based we discussed at the last of the first unit. So what is happening is RAD is used when the staffing is more but the time is less. Okay. So if the requirements are well understood but project scope is constrained, we choose RAD approach. Okay. What is the scope of project? The project should be delivered within 60 to 90 days. The time span for development is functional development is 60 to 90 days, 2 to 3 months. So we see this diagram. In this diagram, generally we generally ask in interviews, and we generally ask in questions that the 60 to 90 days compromise of what activities. Okay, all 5 activities or certain subset of the activities. So you can see from this box that the 60 to 90 days cap is limited to modeling and construction approach only. Okay, communication and planning is done before the RAD is applied, and deployment is another part of that particular RAD approach. So how it works is, When I get the communication requirements and I done with the planning, I will divide that work product into the complete task into multiple teams, parallel teams. Okay, team 1, team 2, team 3, or team n. Okay, all the three teams start working on their subjective parts. Whatever part they have given to, they start working the modeling and the construction part. They start doing that. Once they are done with construction part by team 1, construction part by team 2, and construction part by team 3, I will club all these three and deploy it with the customer. uh, Deploy it to customer. Deployment might be done. So but the only issue you can see here is, if you want to apply this approach, RAD approach, the dependency should be less. Okay, team 1, when team 1 is doing, the team 1 should do in complete isolation. Team 2, team 2 should do in complete isolation. It should not be the case that team 1 is looking for team 2 and team 2 is looking for team 1 for the work. Okay, so it should not be the case. So for this RAD model to be applicable, first thing is the staffing should be enough for you because you want to create teams. Second thing is the team should work in isolation. Okay, and third is, because to want to speed up the process, you need to use components. You don't have to build the components easily. Like, you have studied components, like you have used stdio.h file, header file, in your first year programming labs. So what happens is, once you the file you have not created, it have just imported, or you have just used it, included into your system. Why you included? Because you don't want to write that printf or scanf functions again and again for your. So that's it's called component based design. For a large but scalable project, RAD requires sufficient human resources to create a right number of RAD teams. Because if your project is extremely large, you need to have extremely large number of resources and teams to create, and managing the teams might be very tedious task. The building the components of for the RAD is problematic in case it cannot be properly modularized. So if you cannot create modules, okay, that work in isolation, how to use that modules in the component based system. Okay, because the modules will be calling each other again and again. In case the technical risk is high, that means I have people which have less experienced. Okay, they are freshers, or they do not know how to work on the particular type of platforms or IDEs, or you can say framework. Then I should not deploy them, because the time limit is very less. I cannot use unexperienced staff in this particular case. Okay, so these are the drawbacks of the RAD model. Is this thing clear? We have discussed two models. One is waterfall model, one is called iterative models. In iterative models, I have already explained iterative model and RAD model. So I'm going pretty fast. So sorry for that. But yes, if you have any question, you can raise that question right now. Any questions from anyone? Okay. So if in case you don't have any questions, we can go ahead with further. Okay. Thank you, Farhan. So the next model, which take care of this particular, the main crux of the iterative model was, the requirement was well defined, but it was not stable. Okay. Now what happens if the requirements are not well defined, and that too they are not stable? Okay. The question now comes in this. Okay, we are again going to into a blur situation, wherein I cannot well define the requirement, and do that too I do not know uh, how stable they are. So in all such cases, we can deploy evolutionary process models. As requirements often changes as development proceed, evolutionary models are iterative. However, they are characterized in a manner that enables software engineers to develop increasingly more complete version of software. Okay, small increments, they will create more practical software than in comparison to iterative models. So there are two type of models that generally come a part of process models. One is called the prototype models, and one is called the spiral models. So prototype models generally means you seen prototypes? Prototypes means a small dummy. Sometimes you go into a toy shop and you can see a dummy of a Mercedes car coming up, a new model which has been like crafted in a small dummy structure, miniature of that particular thing. So you can open the door, you can open the different parts of that particular, you can operate that particular thing. So you can have a look and feel how this actually things looks like. Okay, so this is called as prototype. In software also, we generally ask we have asked to create prototypes. You can create a prototype of a website. How you can do it? You can create an HTML version of that website. The website will have a very limited functionality, only drop downs, only objects, only navigations. But actually, the customer will be able to see the look, the feel, the objects that will appear on the screens. And if he able to see the look and feel and the objects that is there, the text that is there on the field, he might feel comfortable. Okay, the fine actual website will look like this only, and this is what I want. So once he is done with one that side, the backend or the further development is much more easier for you. So this is called a prototype. A customer defines a set of general objectives for software but does not identify detailed inputs, processing or output requirements. So he doesn't have knowledge about how the things will be done or what actually he wants, right? But he has a general idea that I want something of this sort. I have seen something of this sort somewhere else. I want to have the same thing, but I do not know the details of that. So something like the very vague statement that's been given by the customer. Likewise, for a developer, you might be unsure of the efficiency of the algorithm that you are going to use, the adaptability of the operating system, and or the form of human-machine interaction that should take place. You are also not sure that how to implement this. So at this stage, you both, the customer and the developer, are not sure about how to proceed. So the thing that I said, that the requirements are not actually well defined, and they are not stable also. So all these cases, this prototype model serves the best thing that you can do, because the prototype model has a quick uh, because this prototype is not actual software, it will have to be done quickly. So you have to plan quickly, modeling quick design, that means you have to design it with the minimum let's set of features that will look like what the customer wants. Construct a prototype, deploy and delivery feedback is done, and then communication again is started. So you have, this is the particular cycle that is followed in a prototype model. That means you can do communication quickly. He will give you the requirements. Based on requirements, you have to create a running prototype. Okay, like might be possible the HTML version of a website, or might be possible to have a small set of interaction hardware module that is coming up, but it should be quick enough. Once you're done with the prototype, you have to deploy it to the customer. The customer will see the feedback, and then with the feedback, you redefine the prototype, or you can start with the coding. Okay, so once you are done with the prototype can be defined into two basic categories. One is the working prototype. That means I created a website, a web page with HTML version only to for the customer to see and feel like what this particular thing will look like. Okay, once the customer says that okay, yes, I am okay with the look and feel and the features that you are enabling in this particular prototype, I may choose to work ahead with this code. I will not like drop this code and start the work from scratch. But what I will do, I will keep on adding the code into this prototype only, and I will create the final work product from this prototype. So this is known as working prototype. It is a working prototype. The developer attempts to make use of the existing program fragments and applies tools that enables working programs to generate quickly. But the only drawback here is because once you are creating a prototype, you might be doing certain compromises. Okay, what do you mean by compromises? That means if you want to put a name of the customer so that he can see the name is coming up, so what you will do, you will hard code it. आप लिख देंगे उसके अंदर हाथ से, मतलब वो टाइप कर देंगे उसका नाम, ठीक है ना. Once you type in the name, and actual software will pick up the name from a database. Okay, actual software will pick up the name from the database, but as of now, because the database is not ready, you have mentioned the name in the code itself. So once you start developing the actual product from a working prototype, you somehow might forget to remove that particular hard codings in your code, in your particular prototype, and this hard coding will then generate issues, because when the actual product will be launched, this hard coding will give the same name for many clients. Okay, it will not pick up the name from the database, it will give you the same name for n number of clients. So the issues might turn up in working prototype, because you have done some compromises while creating this working prototype. The other type of prototype model is called the throwaway prototype. In this, I created a dummy prototype for the customer to look and give his feedback. Once the customer says that I am comfortable with the looks and the content of that particular thing, I will throw away all these particular dummy things and start developing the actual product from the scratch again. From the scratch again. Okay. So this is called as the throwaway prototype. Now there are some drawbacks of the particular prototyping model. The customers can see what appears to be a working version of the software. This is the advantage. However, when informed that the product must be rebuilt so that the high levels of quality can be maintained, customer generally demands. Okay, so you have to like use the same software, and that in that case you will make some compromises, and you that thing will be problematic for you. So we will stop here, and we will start with the spiral models in some in the next uh, whatever time we will suggest. Have a small quick half an hour uh, session again, and we will do away with the rest part of the unit 1. So do you have any questions as of now?